This first crawl space, we see a large puddle sitting on top of the ground poly. In the second view, we're looking at water wicking through the below-grade walls. All of this extra moisture in the crawl spaces leads to a new building problem, crawl space mold. Crawl space mold ranges from light spotting to heavy staining, and more homeowners and builders are becoming concerned about crawl space mold because of the potential health effects it may be having on people that live in these homes. Here's some keys to think about to control crawl space mold. Mold will grow on wood and any other organic material when excess moisture is present. So what you need to do is to eliminate water leaks and standing water, and particularly when it comes to crawl spaces, is to keep the crawl space moisture levels below 70%.
Here's our field study test site. It's a 12-home subdevelopment located in eastern North Carolina and the town of Princeville. These homes are located on a cul-de-sac street. The house size is 10,040 square feet.
When we look at the back of the houses, we can see that the site is well graded for drainage. The home site was elevated approximately 3 to 4 feet above grade to raise it above the 500-year floodplain. During the experiment setup, all crawl space related moisture issues were resolved. These efforts included correcting construction, grading, and drainage problems, sealing any foundation holes that could allow water entry, and fixing plumbing leaks. The crawl spaces in these test homes average about 2 feet high, and virtually all of the wall area in the crawl space is above grade. 10 standard size 8 by 16 inch foundation vents ventilate the crawl spaces. Looking at this site plan, you can readily see how the experiment was set up. The 4 houses are the control group. The control homes are wall-vented crawl spaces with the foundation vents left open all the time. And be sure to notice how 100% of the earth floor in these crawl spaces is fully covered with a ground vapor retarder of 6 mil polyethylene. Coming back to the site plan, the remaining 8 houses are the experiment group. These crawl spaces were converted to closed crawl spaces for the field study. We did this by carefully air sealing the exterior walls of the crawl space. In this shot, you can see workers using rigid pink foam board to seal off the foundation vents, as well as the wall hole for the duct connection to the outdoor packaged unit. In addition to the wall sealing work, we installed crawl space liners to minimize water vapor entry from the earth floor and through the masonry walls. The liners were created by extending the 6 mil ground poly up the walls. At the top edge, the wall poly stops 3 inches short of the wood sill. This provides us with a clear termite inspection strip. We use duct mastic to seal all edges and seams of the poly liner. To monitor the moisture performance of the field study, we rely on small battery-operated data loggers. These sensors, which are installed in the crawl spaces, the homes, as well as outdoors, record the temperature and relative humidity every 15 minutes. In the first 2 years of operation, we have now accumulated over 5 million readings. Let's take a look at a summary of this data. We can use this graph to compare relative humidity conditions for the summer of 2002. The first line to draw in on the graph is the outdoor conditions. Since this test site is in the hot and humid climate area of eastern North Carolina, it's not at all surprising to see that outdoor humidity levels stayed high most of the summer. Now, let's display what happened in the control group of wall-vented crawl spaces. As this line draws in, notice how closely the crawl space moisture levels follow the outdoor conditions. These crawl spaces stayed damp with relative humidity levels above 70% most of the humid summer. Finally, we can show the experiment group performance. In sharp contrast to the wall-vented crawl spaces, the moisture level in the closed crawl spaces did not follow outdoor humidity conditions. Instead, the closed crawl spaces stayed dry with relative humidity levels below 60% all of the time. This next graph shows what absolute humidity conditions were for an entire year in the field test. Absolute humidity is a measurement of how much water vapor is in the air. And this graph reveals that during the winter, both the wall-vented and closed crawl spaces reached their driest conditions, and they ended up performing about equally well. Since winter ends up resulting in drying conditions for both groups, crawl space moisture control efforts really need to focus on the wetting effect that hot, humid weather has on wall-vented crawl spaces. Now let's summarize this graph information in table form. From June to August 2002, the wall-vented crawl spaces stayed above 70% relative humidity 79% of the time. and they stayed above 80% relative humidity 39% of the time, while the closed crawl spaces never got above 60% relative humidity. To effectively prevent mold blooms, crawl space moisture levels should be kept below 70% relative humidity. These results also bring into question the effectiveness of ground vapor retarders in controlling crawl space mold. Many building professionals have thought that a full coverage layer of 6 mil poly on the ground was the main strategy needed to control crawl space moisture. The field test results do not support this belief when it comes to mold prevention. Despite the carefully installed 100% coverage ground poly, excess moisture continues to enter and remain in the wall-vented crawl spaces. This excess moisture creates a damp, mold-friendly climate and humid weather conditions. In addition to space moisture measurements, we also record wood moisture content. A total of 10 pin moisture readings are periodically taken in the crawl spaces during data collection trips. The pin moisture readings parallel the space moisture readings. The closed crawl spaces have lower wood moisture content than the wall-vented crawl spaces, particularly in the summertime. Dry wood framing discourages surface mold, wood rot, and insect infestation. The field test has operated for several years now. The experiment has operated long enough that the moisture performance characteristics have become stable and predictable. Here are the key moisture results. The chief finding is that the closed crawl spaces stay significantly drier than the wall-vented crawl spaces. Second, the foundation vents add excess moisture to the crawl spaces during wet and humid weather, particularly in the summertime. This excess moisture promotes mold growing conditions. The last finding is that ground vapor barriers by themselves do not keep crawl spaces dry enough to prevent mold growing conditions.